happy to be here with you. Wish you were here. We're starting a new term, new chapter, well, sort of. This is the second half of chapter 3. But I'm really excited. I love starting new things because it means it's we're starting fresh. All of you right now have an A in the class. So let's try to hang on to that. And anyway, let's start with this chapter. 3.5, solving polynomial equations. So you'll notice I have a picture of a tree. Here's the grass line, and these are the roots. This is what I think of when I think of solving polynomial equations, and we'll talk about that. So, what does solving a polynomial even mean? So we've been talking about polynomials, and what I know you guys love the best is to factor them. So what does it even mean when we solve them? I mean, in order to solve something, it's got to have an equals, right? So finding all the values of x that make f of x equal to 0, okay? These are called the roots, like I showed in my tree, or zeros of an equation. So basically what we're doing is we're taking the polynomial and we're saying equals 0. And then we have to solve that and find the values of x that make that 0. Okay, so first of all, I do want to cover one thing, and that's the zero product property. What the zero product property says is that if you have two or more things that are being multiplied, and your answer is 0, then it means that one or more of these has to be 0. So this could be 0. B could be 0. Okay, C could be 0. And then I could have, maybe A and B are 0. But if it equals 0, then one of the factors in here, if it's being multiplied, at least one of the factors has to be 0. So say we had an example that looked like this. We had x plus 1 times x minus 2 equals 0. Well, that means that one of these has to be 0. And I don't really care which one, so we have to take into consideration if both of them are 0. So what is it here that makes x 0? Well, I can set that equal to 0. And I subtract 1 from both sides, and I have x equals negative 1. So over here, x minus 2 equals 0. I add 2 to both sides, so x equals 2. So in order to make this statement true, the values of x that could make this 0 are negative 1 and 2. Because if I threw a negative 1 in there, it would make this 0. If I threw a 2 in here, it would make this 0. Okay, hopefully you can get a little sneak peek of what it is that we're going to be doing. Okay, so how to solve a polynomial by factoring. This is one of the reasons why factoring is so important. All right, so we're going to factor this, and then we're going to look to see what values of x makes those factors equal to 0. So first thing I'm going to do is I'm going to factor out a 4. And I'm left with x to the 4th minus 10x squared plus 9 equals 0. All right, now I know I've had some like this on a homework assignment before. Don't let that hang you up too much. This is an x to the 4th, this is an x squared. That just means that instead of an x and an x being here, I'm going to have an x squared and an x squared. Okay, so what multiplies to give me 9 that adds to give me negative 10? We have negative 9 and negative 1. All right, well 4 is not going to equal 0. All right, but what value, actually, hang on. I need to factor it a little bit more. I've got x plus 3, x minus 3, right? Because these are differences of two squares. This is x plus 1, x minus 1 equals 0. Okay? So the values of x that can make this 0, well, here it would be -3. Here it would be +3. Here it would be -1, and right here is 1. Now I could have gone here, I could have stopped there and not factored it anymore. And I could have said, well, x squared minus 9 equals 0. I take the square root of both. X equals plus or minus 3. And right here, x squared minus 1 equals 0. X squared equals 1. Take the square root of those, so x equals plus or minus 1. And we get the same answer. So x equals 1, -1, 3, and -3. So if I put in 1, negative or positive 1, or negative or positive 3 into this equation, I will get 0. So these are the zeros or the roots of this function. Okay, so let's do another one. This one I can factor out a 2x. So I've got 2x, and then I'm left with x squared minus 6x plus 9 equals 0. Okay, so this one, what multiplies to give me 9 and adds to give me -6 is x minus 3 and x minus 3. Well, it's -3 and -3 multiplies to give me 9, and the two of them added together gives me -6. Okay, so in this problem, I had pulled out a 2x. So if x is 0, that makes this 0, and this -3 and this -3, but it doesn't matter because this is a 0, which makes the whole thing 0. So x equals 0 is one of my roots, or one of my zeros. The other one, these are the same, so the other one is 3. Okay, now what this looks like on a graph that I want to show you here is this function looks like this. And it makes sense because it's 2x cubed, so it's going like this. All right, but I want to show you a close-up here of what, oh, I thought I had one. Never mind. Well, right here, what I've got, here are my zeros. There's 0, this is 1, 2, and 3. Okay, so there's 3. But what I want to show you is when we have duplicates like this, it means when we have 2, it means that it bounces off. It does not go through 3. It bounces off. Okay, so 2 means that it bounces off. Okay, I am going to do, I'm over time, so I will continue on the next video.